Friday night. Normally I'd be going, man, I hope y'all are having a safe night, not out drinking and partying, but it is COVID time, so we don't have to be as worried about all of that. But a little unfortunate news tonight. And a little unfortunate news tonight. Angela Joyner and her husband Randall have passed away from COVID or complications from COVID, however you want to say it. I had seen a message from her yesterday talking about Randall had passed and that she was being moved to ICU because she couldn't breathe on her own anymore. And then all of a sudden, about an hour ago, I started getting flooded with questions and messages that did she pass and that she had passed. So I was on her Facebook page a little while ago, and on her Facebook page, everybody's just paying their condolences. So if you were a friend of Angela, or if you knew her or you knew anything about her, wish her the best. She's on the other side now, so at least she'll know the truth about ET while the rest of us are still wondering what the hell is going on. But on that note, I'm going to turn y'all over to Dr. John DeSalvo, and he's going to bring y'all up to speed on what we're going to be discussing tonight. So, John, the floor is yours.
Well, thank you, Joe, and I'm really excited about the show tonight. There's I don't want to say few topics, but there's certain topics because I am a physicist and a biophysicist, and my specialty is string theory and all the weird science. And I get more questions about this topic, dark matter and dark energy, than almost any other area of physics besides string theory, which again is something I'm very interested in. And I for some reason, in all the shows we've done, I've never thought about doing a show on dark matter. Maybe because I feel it's, when I teach that in a physics class, I have to use Einstein's general theory of relativity. You have to have differential equations to explain it, especially dark energy. And so it never dawned on me that, I could do a 2-hour show on dark energy without any equations. One of the things I always felt a strong point of mine in physics was I could take complicated topics and make them simple. So we're going to talk about an area, and this is weird because we're going to be talking about something that actually has never been seen, measured, or quantified, but most physicists believe it exists because it explains so many phenomena in physics that we didn't know, and even reverses some original ideas we had about the universe. But I wanted to read you something, just a quick paragraph before we start, from my good friend Michio Kaku's book, Parallel Worlds. This is just kind of like an introduction to show you the importance. This is about dark energy. Now, we're going to be talking about both dark matter and dark energy, but the greatest surprise the scientific community had was they found out through satellite and other type of data that 73% of the universe, which by far the largest amount, is made up of a totally unknown form of energy called dark energy or invisible energy hidden in the vacuum of space. And in fact, a lot of people don't know this. This was introduced by Einstein himself in 1917. And then he later discarded this theory of dark energy, and he called it, quote, Einstein, his greatest blunder. And dark energy, or the energy of nothing or empty space, is now reemerging as the driving force in the entire universe. And this dark energy is now believed to create a new anti-gravity field, which is driving the galaxies apart. We thought they were coming closer, but they're not. The ultimate fate of the universe itself will be determined by dark energy. So just to give you an idea, this is not a trivial topic or some kind of new age. People throw words around in science that don't really understand what they mean, especially in the areas of quantum physics and relativity and string theory. But let's start at the beginning.
Before you go, no, because you made a good point about that. I remember, God, I don't want to give my age at people, but I remember we're going to go back about 25 years here. And I remember somebody coming up to me we were at an election. Somebody said, what's dark matter? What's this? I hear it's just new age bullshit. I'm like, what do you mean it's new age bullshit? It's science. And they're like, no, Joe, it's made up stuff. I'm like, made up what? I said, wait, because I was just confused at this point. I said, look, we don't exactly know what it is, but I said, we do think. And I said, I used the word think. I didn't want to, put any strong words out there, that this does exist. And it does comprise a large chunk of our universe. And they're like, Oh, well, how can that be? Because it's fake. So I just wanted to bring that up, people. It's not actually a fake subject. It is actually real matter. It's it's not pseudoscience. It's real science. But go ahead, John. Sorry.
No, and that's a really good point, because I mean, it's really strange, because I have to state, we've never seen dark matter. We've never measured it. We haven't identified exactly what it is. We know what it's not, and there's a lot of theories and hypotheses what dark matter is. Again, I'm starting with dark matter, and then we'll talk about dark energy later. Now, we have some guesses. So the question is, why do we study it? So what? Well, the reason is, and what Joe said was really very interesting and very true. It's made up, in a sense, that by assuming dark matter exists, even though we can't see it, measure it, or put it in a bottle or a test tube, it explains some of the most incredible observations in physics that we could never explain before. And in one case, we thought the universe, the entire universe, was acting a certain way. And now we're finding out, through using the assumptions of, maybe that's a good word, the assumption of dark matter and dark energy, it's completely opposite. And that blew a lot of physicists' minds. So in a sense, yes, we don't really, it's like string theory. String theory is a concept to explain how certain things work in physics, but nobody's ever seen a string, or we're not even sure they exist. But it explains mathematically a lot of things. Now, because you know, we're going to be talking about several things about dark matter, and there's the four main things that dark matter explains. So I want you to keep these in mind, and then we'll go into each one. Galaxies rotate in a very strange way, and nobody could explain it until the idea of dark matter came around. But before I do, well, maybe before I should do that, I should give you an example of how much dark energy and dark matter do we think we have in the universe. Is it 1%, 2%, a lot, a little? So to give you an idea, all the matter and energy in the visible part of our universe, meaning, the stars, the trees, our Earth, everything that's everything we can see, measure, touch, that stars, galaxies, comprise less than 5%
Yep.
of the total universe.
He's not lying to y'all either, people.
Right.
We're the light fighting the darkness, just so y'all know that.
That's interesting.
I mean, it's true. I mean, we really are. Let me put it like this. I'm gonna let John go back to explain this to y'all, but we are the minority in the universe. And when you look out at the universe and you see all those stars, you think, oh wow, all them people out there. But every little white dot or every little blue dot or whatever color dot is, you have to think of what's in between them and how much distance and what fills that area. And that's what we're talking about.
Remember in school, in chemistry, they say the atoms we think are everything is solid, the desk we can touch, but there's so much space between atoms. But so what we think now, the whole visible cosmos is less than 5%. Dark matter, we think compromises 20 to 25%, which is about 1/4 of the entire universe. And wait for this, dark energy comprises 70 to 75%, almost 3/4.
And that's a downgrade, people. Actually, it used to be a higher percentage than that.
Yeah, in fact, they keep fudging it. Like the visible part keeps getting smaller and smaller. So
but it's going to change. And I mean, let's be honest. The more we learn about space, the more it's going to change. But I remember the very first one I ever heard said dark energy, dark matter, because they were just mushing it together back then. It makes up 98% of the universe, and 2% is light. Well, that has changed since then, ladies and gentlemen. Like John was just telling y'all. But again, to whoever just sent me that instant message, this is real science. Whether you believe in dark matter or not, this is real science that's telling you what we're expecting to find and how we're expecting to find it. And that's what this is really about. And I don't think y'all understand. If dark energy is what they think it is, it will revolutionize our planet if we can ever get to it.
Exactly. Well, what you said was very true, and that is, the question is, okay, if it's not just something in our minds that we made up. And here's some examples of what it explains to give you an idea how significant this discovery is. Remember, Einstein said it was, quote, his biggest blunder to discard this whole notion. But we're going to find out later in Einstein's equation, he put in a constant that actually gives us information about dark energy and explains the expansion of space. So this stuff gets really deep. And again, a lot of it, you really need the mathematics. Now, when we look at our solar system, right, Joe, the planets rotate around, the planets closest to the sun move faster around, and then Earth's slower. You go down to Jupiter and Pluto, and it takes forever to go around.
What is Jupiter's orbit?
You know, that's
234 years. Is it so?
So
Damn,
well,
you're old. I mean,
so
we'd be old. 1 year, you'd be old. Good. I'm sorry. Good.
Yeah. Well, so the idea is that our solar system revolves through typical Newtonian physics, and we would expect a galaxy to rotate like that. Material closest to the center of the galaxy should revolve around the center faster than the material at the edges of the galaxy. But what we find by observing the galaxies, which we can see, that they rotate the same speed. Like the galaxy is like a pinwheel, like a record. So you revolve the record, everything moves around at the same speed. Now that's crazy. That is opposite of the solar system, and Newtonian physics cannot explain it. And we'll be talking about that. But dark matter, they believe, fills in those areas that we're surrounded with dark matter, which is energy. And well, the dark matter has gravitation. It has the force that's keeping all these things by moving together. Now, the other question is, you look at the galaxies, like a cluster of galaxies, and there's a whole cluster of galaxies, and they are kind of stay together. They don't fly apart. But if you try to calculate the galaxies, where they should be, their rotation, their movements, if we use what we know in physics or modern physics calculations, the galaxies should fly apart from each other.
They should, but they
don't.
They
so
don't.
Something is like tethering, keeping them together. And that, we think, has to do with the dark matter.
That's a good segue for a moment. Guys, we always talk about Big Bang and how the universe came to be. One of the sticking points is Big Bang is the way the universes move, the way the galaxies move. I'm sorry. Because some of them cluster together and stay in certain positions. Some move off at different speeds and different rates. And then some have a tendency to stay relatively in the same area for long periods of time while eating other galaxies. It's a strange thing that goes on out there, which suggests there's another source of gravity that we don't know about, or another source of energy we don't know
about. Yeah, those examples really don't have to do with dark matter. But the other third thing, which is interesting, is, and this is really crazy, we always thought the universe, and if you study the Big Bang and you plot it out and the expansion of the universe, our calculations showed that the universe was contracting, because after the Big Bang, it spread out, and now gravitational forces of the different, material is kind of bringing it back, and the galaxy was decreasing. But we observe now through redshifts and different other things, which I won't go into, the galaxy is expanding. And it's like, what? Why is it expanding? We'll talk about this later. And that has to do with dark matter and Einstein's equations and constants. So once you put that into the equations, it shows the universe is expanding, and it's because of the dark energy. And there's also missing matter in the energy. So the idea is dark matter is not just something we're going to make up and so what. It explains really important things. Why galaxies rotate the way they are, why the galaxies in a cluster don't fly apart. It's almost like a spinning wheel with water on it. They expect the droplets to spin off, but they don't. They stay together. So not only do the galaxies are tethered together, but each individual galaxy should be spinning off its material like a wet wheel, but it doesn't. Again, due to this matter, which we don't see, we can't touch, and we can't hold. And by the way, right now, dark matter is coming, if it exists, is coming through us on the earth, coming through our bodies. It's everywhere. And but we can't feel it or identify it. So I wanted to make that clear before I kind of talk a little bit about the history of it, because I think that's like, of anything, it's important. You know, who first discovered it? How did it progress to where it is today? And then I'd like to go into the details of dark matter. And also, we'll talk about a famous, you're going to love this. A lot of times, I love the idea of women in science. My daughter's a biomedical engineer. She works on the vaccine project with a big pharmaceutical company. But there's a lot of opportunities for women in science, and women have maybe been ignored. And there's a lady we'll talk about who really put dark matter on the map, and they expected her to win a Nobel Prize. And unfortunately, she was always passed up, and everyone was wondering why. Well, the morning she died, she was 88, she got a call from Stockholm. And so she never really got it. And it was a really blunder in terms of the Nobel Prize, because she should have gotten it. But we'll talk about her in a little bit. But 1930s is really, well, besides Einstein's equations, 1917, the theory of relativity, and we'll talk about the gravitational. But the observations was around 1930s, there was an astronomer, professor of astronomer at Caltech, known as Fritz Zwicky. And he is the one who realized that these, and I may be repeating some of the early 4 or 5 statements that I made. He realized that the outlining galaxies, a whole group of outlining galaxies, a cluster of galaxies, he looked in the Cosma cluster, which is a specific group of galaxies. And they're about 370 million light years away. There's probably thousands of galaxies in the Cosma clusters. And they were moving, again, far too quickly for their visible matter to adequately produce a gravitational force to give them together. They should be flying apart, because if you look at what you can see, and astronomers can calculate the mass and weight, the galaxies, and when they look at it, all the equations say they should be flying apart, boom, all over the place, spinning off like water off a wet wheel. But something was keeping them together. And this was, again, 1930s. And then 1936, and I think it's important that in science, things be collaborated, by other scientists. Mm-hmm. But in 1936, Sinclair Smith of the Mount Vernon Observatory looked at the Virgo cluster, and he came to the same conclusion. And I thought, okay, so now the astrophysicists are saying, okay, something's going on there. These clusters should be flying apart, but they're not. They should be moving. And then if you looked at an individual galaxy, they don't rotate like our solar system. They rotate like a pinwheel. Well, the next 30 years, there was more and more confirmation of this. But the greatest, I think, work done on dark matter was done around the 1970s, and that was by the lady I mentioned. Her name is Vera Rubin. Vera Rubin, she was at the Carnegie Institute of Washington, and her with Ken Ford, sometimes known as the Rubin-Ford effect, they basically studied the movement of stars within the spinning galaxies. And that's not only did the galaxies not spin apart, but the stars within the galaxies that we talked about also stayed together where they should be flung out, like a rotating, wheel with spinning things away. Now, the problem was, again, to repeat, our scientific, and this is how science works, like you have gravity by Newton. Then you find out it doesn't work for everything. And then Einstein came out with a greater and bigger encompassing theory. And then they come out with other theories. So science keeps progressing. And this is what's been happening with this dark matter. Now, Do you have any questions so far, Joe, on
Oh
this?
well, actually, no, I was just letting you go because we got some stuff, but we're gonna wait till the next hour. Because when we get into the next hour, we're going to talk a little bit about Stacy McGaw's, some of the research that came out just recently. So there's a lot of stuff out there about this, guys. On as far as that goes, on both sides of the coin, whatever. Well, no, I don't have a pony in this hunt or a dog in this hunt. I like the universe, and whoever comes up with the best theory and makes it work, I'll be behind. So it doesn't matter to me. I
You,
just
you,
want somebody to get it right. Yeah, that's all I'm saying. And
you know,
I've been
I
a
like
big
that.
follower of
Yeah.
Dark Matter for a long time now. We're going to talk about Stacy when we come back because Stacy takes a different approach on this, and it's a little bit different. And we'll talk about that. But anyway, because John was in a good groove there. That's why I wasn't interrupting you. We're in a good
Oh,
groove.
that's okay. If
Well,
any,
and because for this kind of stuff, well, no, I'm gonna stop him every once in a while because I don't want y'all to fall asleep
right.
because science can get you. When you just anytime we talk about science, we got to stop every once in a while because some of the audience is like, "What the hell are these two idiots talking about?" And some of them are like, "Don't stop," and some of them it's a different kind of subject
Well,
because
well,
it's
I'd
not a
like this
fictitious
like
subject.
no,
Go
I'd
ahead,
like
bro.
this like a classroom. So, are there any questions? I don't mind
Not
stopping.
yet. Not yet.
Feel,
Everybody just seems to be listening. That's all I
yeah,
see so far. You know what?
yeah,
I'm
feel
glad
free
you
to
said that.
interrupt
Do
me.
I need to see the other chat room? Damn.
Yeah, no, with the chat room, feel free to interrupt me
Let
if
me,
there's any
let me,
questions
oh
because
yeah, let me pop into this one.
yeah, I wanted this to be more like a classroom because I'm going to be going through a lot of material and probably going to take the full 2 hours. And I want to make sure that, questions pop up in students' minds, then they kind of forget them. So sometimes it's good to, but the other thing is that here's a good analysis. If you see a person with doing a mem, he has say white gloves and he's completely dark, dressed in something dark, and they have a light on him, and all you can see is his gloves. That's a good analogy. The gloves are like our physical world. We can see that less than 5%, but the person's whole body is maybe 95% of the mass, which we don't see. So it really controls everything. So I remember reading about that analogy of the white gloves, and I think that's a good way of looking at it. That we're just can observe that white gloves of a person, but the rest of the body is the dark matter, dark energy, which is actually more important, or not to say more important, has a greater gravitational and energetic effect on the universe. Now, I'm, I'm given a lot of statements and explanations, but remember, we haven't seen dark matter. We haven't measured it. We haven't measured it directly, but because dark matter is very dense and dark energy, it could bend light like an Einstein's theory, which proved it was correct. Like a light passing by the sun from a star is bent because the sun's gravitational field bends the light. So it's called an Einstein lens. We could actually see the effect of dark matter and dark energy if it exists by its bending effect of light. So again, that's kind of indirectly, but again, it's like string theory. It explains so many things, but we haven't seen it. Um, it you can also picture like the whole universe floating in a sea of dark matter. We're not really sure, but when we get into dark energy, we're going to talk about how that affects the fabric of the universe. And this is really interesting new stuff because I have a theory, which I hope to get in tonight within the time. If not, we can do some next week. But I've tried to incorporate this into my theory of multidimensional space, which and multi but we'll see how that goes. So, what are the possibilities? Um, Again, no one knows. Some think it could be an exotic particle. It's definitely not like a neutron, proton,
No,
electron,
it's not.
or the subatomic particles.
Maybe
Um,
it's like a plasma of some sort.
well,
Uh,
it could
we
be.
haven't been far enough out. Sooner or later, Voyage is going to get far enough out there to get itself into what we consider dark matter. It would be nice to find out if it was like a fluid. Or I don't mean like people. When I say fluid, I don't mean fluid as in like a liquid like you're thinking of. I mean fluid in its movements, maybe an energy, a plasma, something something that the planets can move, the galaxies can move freely in, but it still has a force on them itself. Like,
Yeah,
because
yeah.
in space there's not supposed to be any resistance in space whatsoever. So if you throw a rocket, it should keep going. Obviously, that's not completely true, because there is things that exert force on galaxies and planets, and we know gravity is out there. So it's not exactly a true statement. But anyway, John, go ahead, man.
Well,
Just a
yeah,
little
and no, that's okay because I'm going to go over some of the possibilities that have been suggested, and then rule some out from what we know of physics. And one was maybe it's some kind of exotic particle which we haven't discovered. Not many physicists buy into that, but it's possible. One theory which was interesting for a while, and that kind of also fell by the wayside. And I'm mentioning this to you because if you read older physics books, you may come up with these, but these have been discarded. They think it could be a cosmic bath of miniature black holes. And that's been kind of ruled out based upon,
yeah.
the physics. One was neutrinos, but their gravitational effect would fall short by over 100-fold and would not explain the phenomena or work into the gravitational field. And I believe the biggest theory right now is supersymmetry, which we call SUSY, supersymmetry. And I don't think I'm going to explain that because it gets difficult, but just in general, supersymmetry really is like a relationship between two basic elementary particles. And those who are physicists that are listening heard of bosons, and bosons have an integral value spin, a whole number of rotating particle spin. They can spin clockwise, counterclockwise, half, three quarters, like quarks. But bosons have an integral value of spin, integer value, and fermions have a half integer value of spin. And the space-time symmetry is what they form, like super partners. And the idea that these particles, which form supersymmetry, could possibly be the essence of dark matter and dark energy. I don't buy it, but I think it's getting closer because I think it's something we haven't even considered yet. But many times, like when they asked Einstein, not Einstein, who was Edison, when he was, I don't know if the story is true, but I really like it. When he was trying to invent the electric light, he wasn't very successful. And they said, you've tried 280 times and you still haven't invented what you're looking for. And he said, well, I know 280 times, 280 ways it's not going to work, And so sometimes remember I said, maybe we don't know what it is, but we know what it isn't. And that allows us to rule out a lot of different, possibilities. I think the black hole theory, which was ruled out, is still a possibility. So even though that's something most physicists probably wouldn't go for, but keep in mind now we're talking about 70% of missing matter and energy of the universe that explains some of the basic physical movements of galaxies and rotations and all sorts of things. Let's see. Though this is really interesting. There's just so much to cover. Want to make sure I covered. Let's see. Oh, okay. Well, maybe talk a little bit about the expanding universes, unless you had any. Hubble is a good one to mention too. Actually, Edwin Hubble in the 1920s. I left him out of my my little history.
Uncle Hubble.
Yeah. He when we first looked out in space, we would see like fuzzy patches before we had these telescopes, and nobody knew what they were. And then because of the Hubble telescope and others, we were able to separate them into galaxies. And that's why we were able then to see individual galaxies and galaxy clusters. And again, that allowed for the discovery that the galaxies don't spin and work the way we think they are. So the other thing is you would need 160 times more mass to cause the motion of the clusters than we see. And so something was going on, and they knew that real early in the century, in the 20th century. But again, no one knew what exactly, what it was. Neutrinos, I like the idea of neutrinos too, because I studied those with Joe Parr. The problem is they're too light, 100 times too light, but it's possible they could be variant neutrinos, maybe something to do with supersymmetry. Now, this is my theory, but it could be off. Axions could be, there's so many things, like I mentioned, exotic particles. But basically, I keep repeating it because I don't want people to go away from this little, presentation and think, oh, yeah, dark matter, we know it exists, we can prove it, we've seen it, we measured it. And no, none of that. This is just, at this point, a construct that explains all these physical phenomena of the universe. But we have evidence of it, like I said, through the Einstein lens, or the bending of light by these galaxies, and their gravitational amount would not be enough to cause this type of bending. So we know there's something there, like the mime with the gloves. We see the gloves, but we know there's something behind it. Or maybe the tip of an iceberg is another good analogy. We see the tip of the iceberg, but there's so much mass below it that we can't see or measure, but we know it's there because maybe we see the way the iceberg, the tip moves in the water, and we say it wouldn't move like that if it was just a piece of ice. There has to be something below that. That's my analogy that I use in class, because I think that's a good way of explaining it. Before I get into the deceleration parameter, which is related to dark energy and things, is there any questions come up, or you have any questions so far?
No, yeah, it's kind of like quiet in here, man. It's kind of like little tumbleweeds going around. I'm gonna have to start picking on people here soon.
I know it's
let's see. Wait. What the hell? Oh, I had a big space come over my screen. Sorry, it freaked me out for a minute. No. Actually, no. You know what, guys? I'll put that up so y'all can see that. No, John, I'm not going to talk about this and the next hour, not this hour. This is a new theory on why or why not dark matter may or may not exist. NBC's actually one posting the article, but it was from the lady, Tom McAfee is the one who did the article. But if it'll scroll, I'll tell you the lady's name, who the researcher.
Why don't you tell us a little bit about that?
But this is, well, you know what? Let me put it on this screen where I can see it, so I'm not looking at the screen halfway across the thing. Now, a couple of days ago, this showed up on my feed, and John, I'm an avid follower of dark matter, dark energy, antimatter, just stuff I'm interested in because of other things that I'm interested in. So I've been keeping up on the science for probably a good 30, 35, 40 years. Well, this pops up on my feed the other day. Maybe dark matter doesn't exist after all. New research suggests. So what this is, and let me go down. I want to properly introduce this lady because I don't want to. Stacy McGraw, who heads up the astronomy department at Case Western Reserve University in Cleveland. Now, her and her team, whoever this team is, and I'm just, they said, they've been watching this for a long time now, and we know about all the dark matter models and all of that, and they started noticing in 150 galaxies gravitational tug on stars at different speeds. And they're suggesting the reason why we always assumed that it was dark matter is because we haven't had the sensitive equipment that we have now in 2021 that can measure these faint observable changes in speed in these stars. Now, ladies and gentlemen, this is very interesting. It says it's very tiny discrepancies in the orbital speeds of distant stars. That's exactly a quote. It says it reveals a faint gravitational effect. So they're saying that if this is true, that it rules out dark matter. Now, this will be a debate that goes on until somebody can actually prove this.
Yeah.
I do find this very interesting, and I won't rule anything out because, we are new to all of this, and there's a lot to understand when it comes to the universe. And I'll be the first one to say that, yes, we're very limited in our understanding of the universe. But I don't want to sell our science short because there's a lot of hard research into what we're talking about tonight. So we just now, and I don't want to take anything away from this Stacy woman either, because maybe she has figured something out, or maybe because of the new sensitive equipment she has. But meanwhile, this is the first one I've seen, and it was a big splash across a couple of my feeds, and then it came across the other feed. And then my wife actually mentioned to me again. She said, "You see this?" I said, "Yeah," because she knows I have an interest in all of this. And I was like, so I went ahead and read the whole article, and I found it very interesting and very fascinating. It was published in November in the Astrophysical Journal. So if y'all want to go read it, you can. The whole entire article's there. They only gave me about half of it here. It does kind of either contradict or bend the current theory on dark matter. But again, until they can prove it now, if a couple other scientists peer review this and then go up and then check her findings with other telescopes or other equipment, then yeah, we may start to have a different climate and a different change. But that would only explain dark matter. It wouldn't rule out dark energy. So I'm not exactly sure how this is all going to pan out. I got to say, that's why I love this subject, John. I mean, the things we're talking about here is fascinating. And to me, there's something about the idea of orbiting in a bowl full of jelly that just tickles me pink, man. And ladies and gentlemen, that's a very layman way to describe it. But you heard John and I talking earlier about different like particles or plasmas or energies, and we don't really know what it is that actually binds the universe together. It is kind of gravity, but there does seem to be some other energies at play there, and we don't know. We haven't been able to reach far enough out. Remember, you always hear our scientists say the observable universe because we can't see all of it yet. So we can only see X amount out there. I think right now the current estimates is 100 billion light years across, 95 billion light years, something. It's huge. Nothing that any of us are going to get to see. John might, because John's been abducted by aliens, but the rest of us ain't going to get to see it. But I would love to be out there in a spacecraft and you see like a ripple effect, like when a boat's going through water and then it breaks the bow, and on a calm day. I can just imagine you're a field out there and your spaceship's going through it, and you can see the ripples around the edges of your craft of some type of energy. And again, it could be completely false. It could be something entirely different, and it may be yet even something else different from that. But guys, it's fascinating to talk about, and the things that you can come up with. I mean, it allows for stuff in the universe that we couldn't think of before. And you got to remember, guys, we have to create new math every time we learn something new in deep space because we don't understand it. And sometimes our current math situations don't exactly give light to what it is that we found. And hey, look, what are we on? Like, how many different types of math now? 9, 10? Shit. Somebody was arguing with me about this the other day, and I done forgot already. Punk, if you're listening, send that over to me. I can't remember how many there were, but it was an interesting conversation. But I mean, you get your basic math all the way up, and I love math. Yes, I love anything that makes your brain function at high speed. What you got, Chris? Okay, Chris is asking us, John. He says, so do you think that if dark matter is real, is it a binding force?
Oh, it's a very good question. Well, it's definitely binding because it's holding. It's a lot of physicists use the expression like it's tethering the galaxies or tethering. So yes, one thing I wanted to mention too, which you're right on with a couple points. If I was giving this presentation to my physics class, they would have had classes in differential equation and general relativity. Yep. And my problem now is it's hard for me to explain, like, for example, the research you just mentioned, if it's the one I'm thinking of, it doesn't explain the cosmological constant enough in dark energy to be a really, a standout theory. There's 2 or 3 others that are kind of different too, but what they do is they get bits and pieces of the explanations. And that's the way string theory worked, by the way. Do you remember Ed Witten, who is my idol? I have actually a signed picture of him. Ed Witten, string theory was going to fall away by the wayside because there were 5 different models to explain it. So how could you have 5 different models explaining the same phenomena? And Ed Witten put them all together in a comprehensive model and is known as the man to save string theory. It's like looking at a violin player from 5 different directions. You would see different things or hear different tones, but when you put them all together, you have one complete model. And I think that could be with this dark matter. Maybe that one group had one idea. They got supersymmetry. We have exotic matter, and but again, when you start to look at each individual theory, it only explains part of what we see. I don't know if I want to sum up again before I go on. I don't want to confuse people, but it's very, very simple. Keep this in mind. We don't know for sure if dark matter exists, but it explains a hell of a lot in cosmology. And it explains, one is why the galaxies, that is complete galaxies, don't fly apart, and they should, according to our calculations. It explains why individual galaxies don't spin off their stars, which it should, because they don't have enough gravitational field to keep them together. It explains why the galaxies rotate like a pinwheel and not like our solar system. And it's also going to explain, and this to me is the most interesting part of it, why our universe is expanding and not contracting. And actually, space is being created. This is really neat. And that's what I'll be talking about in a minute. But so that's where we kind of are now. 95% or more of the universe, we believe, is composed of dark energy and dark matter. And the rest is our visible luminous world. So I hope that gives people an idea that this explains a lot of things in physics that we had no idea how to explain it. And
Stephen is writing in from Sydney. He says he is a second-year astronomy student in college, and he said he wanted you to clarify something when you're talking about tethering. Do you mean like a physical strand of energy going from one galaxy to another, or is it just some type of forced energy, or is it just like a blob of plasma stretched out connecting?
Yeah, good. Good question. I didn't go over that. Look at it as a big, like a big ink block, a big blob of. Let's just take a piece of paper, and just put a whole bunch of ink all over it, and then plop in the galaxies, and that's what it's like. So it's not like we don't even know what it's like, but the models is based on it. That we're like in a sea. The dark matter maybe is like a sea, and the galaxies, the stars are kind of plopped in it, and we're in it. It's going through us. So it's not like, as far as we know. I mean, now that could change. Maybe somebody will come up with it. But that's an excellent question. And anything else that before I do?
Who is this? Hold on, let me go back. I just had one in front of me, but I'm the damn.
This is great. I love these questions. Reminds me of my university.
Wait, where did I do with it? Oh man. Anyway, I'm gonna have to sum this up because I had the names in front of me, but I don't know what I did with it now. He was talking about. He's also in astronomy, but he's actually works in Hawaii. Oh, okay. I know exactly where you are, man. Y'all got cams up there. I look up there all the time with y'all. That place is fabulous. Oh, yes, it is. Anyway, let me get back to the question. So he was talking about the two guys who originally found, it was Ford and I forget the other guy's name, who originally found the things that made the other scientists think that it was dark matter. But he said the original two scientists who found this didn't actually agree with the dark matter theory. They just didn't have a better one. That's pretty good. I don't know if that's true or not, though, man. I'd have to go verify.
I love it because I hate to say that, but in many times in science, that's kind of the case.
That probably is too.
I love that. I'm trying to think. It's basically, it was the Rubin Ford effect, and that was in the 1970s. I think.
That's it. That's Rubin. That's the name. Yeah. As soon as you said it, subatomic particles, guys. Yes. John, do me a favor. John can explain this better than I can. So, because I'll have to do a cross between science and layman. So we'll just let John. We had two people come in and said they don't quite understand what a subatomic particle is. They understand particles, the energy, and stuff like that. But when they're talking about subatomic, the question really is this like a layer underneath our reality, or some type of subspace, or what is it? Do they exist separately from where we exist? I guess is the real question.
Yeah, I'm going to do it real simple because actually, I had a whole lecture on subatomic particles. But if you look at, originally they thought the atom was the smallest piece of matter that one could divide. That was it. The atom was the basic unit. Then they discovered, no, it has electrons, protons, and neutrons, as we all know. who anybody's taking chemistry.
Yep.
And then they
Yeah.
found out now the electron is nothing smaller than the electron. You can't break an electron down any smaller. So that's a fundamental particle. But the neutrons is then composed, the nucleus is composed of protons and neutrons. And the protons and neutrons can be taken down to smaller particles. And I don't know how many. They keep
That's
3,
what those
4,
little
5,
numbers are for, people.
500. And so that's what subatomic particles are. And that's what CERN does. Basically, they split atoms and they look for more. And I used to do this when I was a graduate student in physics. We had a particle accelerator and we looked at those things that look like, pathways, circular. We would look at those and see where an atom was smashed and certain energy or particles were kicked out. And by looking at their velocity and mass, we could determine what they are or discover new particles. So, and that's all part of this too. Now, why this is important maybe in dark matter is we haven't ruled out exotic particles, the supersymmetry, which could involve subatomic particles. So, that's a good question. That's another show, by the way, the whole idea of history.
Yeah, Julie from New York wanted to know, is the Higgs boson a subatomic particle? Are you a CERN follower? I mean, you know about the Higgs boson. I'm just curious if you're CERN. I get 3 emails a day from them crazy people. No, I don't do. I told y'all this 8 years ago, 10, whenever the hell this was. Everybody said, "Oh, CERN's going to split an atom and split a particle and destroy the planet." Well, guess what, guys? They haven't yet. And you know what? If they do, and it's like one of those implosions, and we'll go so fast we won't know it anyway. And besides, we might pop out in another universe or another dimension for that matter. So don't worry about it. I hate when people do that. Use real
remember
science.
the Manhattan Project, Joe. You remember they were afraid when we exploded an atomic bomb,
That's true.
Remember that? Was that
I also remember when they thought if we put a gas station on every corner, that it would be wreaking fire across the entire country. People, really?
I never heard that one. I love that.
Yeah, oh yeah, back when this first started. This is true, people. You can look this up for yourselves. When gasoline cars first came out, and they thought about putting a gas station on every street corner, people freaked out. Oh, there'll be explosions, they'll be blown. Of course, it never did pan out like that. But the reason it got brought back up is because now we're trying to put hydrogen stations. And people are talking about, oh, a hydrogen bomb in my backyard. It's not exactly true, but I do understand. What was that, Glinda? Oh, Fritz Zwicky. I do remember Fritz Zwicky. And there is a big argument that he may have proved the existence of I actually do remember that. That's I learned that back
that was the 1930s at Caltech.
What was he, 32, 33, 30? So anyway, it was in the early 30s. It was somewhere right there in the early 30s.
He actually looked at the clusters, not the individual galaxies. And he was.
I'm impressed you knew that. You're just a layman. Yeah, well, I'm glad. I'm a little bit more than a layman.
You know what? This is great. These are some of the best questions we've ever had on the show, and it's and this is what I like.
Oh, now this one. I don't know this. We're going to ask John. We're going to talk about this one a little bit. So, stop typing for a minute because you're moving the screen. I want to read it. Could black holes cause dark matter, or could they be? You're talking about like mini black holes, like what they talk about. Like they talk about the ones that popped up in that place in Louisiana. I know what you're talking about. Micro wormholes. He's wanting to know if micro wormholes could be like netted together to cause what we would consider dark matter, like a beehive thing, right? Is that what you're talking about? So you're talking about lots of little micro wormholes compressed together and like a beehive form to hey, good theory, dude, but I have no idea. What do you think, John? I have not a clue.
Question. Ask him if he is a physics student.
Yeah, he's a teacher, not a student.
Okay, because that actually was the theory of dark matter, that it's a cosmic bath of miniature black holes, very similar to the way he explained it, So, I mean, most of the, from what I know, most of the astrophysicists
down in California, but you don't want to say where because
you don't. No,
that's fine. That's fine.
That used to be one of the leading theories. It's excellent. So,
it's great. We're happy like that. Oh,
Anything?
you're talking about Stacy, what we were talking about earlier. What no, Stacy's theory just got published in November. I mean, it just came out, so a lot of people aren't even aware of it yet. It's out for peer review, so it's new, it's good. I've heard a lot of astronomers go off on it now, and they like it. But you know what? It hasn't been peer reviewed yet. So when it gets peer reviewed, John and I will bring that back on here, and we will
Yeah.
compare that against what we're talking about here, and the
And
same thing.
and
We'll
I'll
give it a
check out.
fair shake. We just brought it up tonight because it just happened to come out as we were doing this show. So
I heard about it. I didn't read the article, but what I'd like to do is, I hope there's a lot of math in it, because that I'm sure it is. I would.
yeah, the original. If you go get the
math.
one from the journal, yes, there is. If you get the article now remember this, ladies and gentlemen. There's a big difference between if you go to NBC and you read the story, or if you go get the journal. Okay,
Yeah.
I just John's laughing because he knows there's a big difference, but no, I mean there's a serious difference. What's going to be in the journal is going to be a breakdown of how they came to this. Okay, and what's in the article is just a guy talking about what he read.
Yeah.
Yeah.
Joe,
I
you're
know.
bringing up such very good concepts, and let me just reiterate that. A lot of, again, I hate the term New Age, but a lot of New Age people are really quick at throwing out ideas and theory, and they think it's fact, but it's just suggestions. And that's nothing wrong with that. Einstein called his daydreaming thought experiments. He imagined what it would be like to ride on a beam of light. And because of that, because of his speculation, daydreaming, he developed the theory of relativity. But the question people have to realize is these are guesses, hypotheses is what science calls them, and they need to be tested. And then once they're tested, like you say, let's say they start to make sense, then somebody submits an article. I remember, like, for my dissertation, I submitted to Brain Research. It was a peer-reviewed journal. Sometimes it comes back. You have to explain this, and so they send it out to experts that are probably better than you are, better than I was when I did my peer publications, and they determine if it's a bunch of horse shit, or the middle road is they'll say, well, you concluded this, this, and this. Can you explain it? Can you give us more evidence? So once it comes out in a respected, like Nature and Science, to me, are the two most respected peer-reviewed journals. And there's others too. But you're right. There's a difference between that and you used to have like the magazine Omni. Scientific American is in.
Wait, you're gonna love this, John. Rubio, who works for CERN, by the way, just sent us their current dark matter hypothesis, I guess what you would call it. I hate using the word theory in this case. So they've got their current on both dark energy. Wow, dude, I understand math, but half of this is jibber jabber to me. My friend John can read this because what are you talking about? Oh no, send it to my email. But yeah, the article's right here. This is great stuff because I'll put this to the other computer where people can actually read y'all's article while John and I are talking. It's one of the nice things about doing live with video. Yeah, it is. But no, I appreciate you. Hey, Rubio, thanks, man. I'm glad to see. Well, I know we have a lot of people in the science field listen to this show because I know from the emails we get now. But I'm just glad to see y'all interacting. Yeah, I love when y'all interactive, man. I love that stuff. But go ahead, John, so I keep cutting you off. Go ahead.
No, this is good. I want to give out my contact information for two reasons. One is if somebody wants to contact me for any reason at all, they can. And two, if they have articles or information. But I think the easiest way to contact me is through my website or the association's website, which is GizaPyramid.com. GizaPyramid.com, GizaPyramid.com. And I'm the director. Email the director. My email address is just CDeSalvo, like Christopher, CDESALVO @goldengate.net. But you don't have to write that down. Just GizaPyramid.com. The other thing is I am on Facebook. I do a lot of teaching on Facebook, and I usually respond to all messages if they're not weirdos, right, Joe?
Yeah,
you know that.
There are some of them out there now,
Yeah. Now, the thing is, I'm at my limit of friends on Facebook, but I do all public posting now. So you don't have to be a friend, but you'll be able to read all my posts, and you can always message me. So I would say Facebook and through the GizaPyramid.com website would be the best ways to contact me. And it doesn't have to be about black matter. It could be about anything. Just feel free to write to me. I've got 12 books published by Barnes and Noble.
Rubio, if you're still listening, Rubio, Why don't you ask around? We'd love to have one of your scientists. We've had a lot of scientists on this network over the years, including Michio Kaku, Neil deGrasse Tyson. We've had some big names. I would love to have one of y'all come on and really just talk about what CERN does. You don't have to give away any secrets. Maybe you could talk a little bit about the Higgs boson and stuff. Like John and I would love it. We would be a captive audience, is what we would be. And both of us are fairly well versed in these areas, so we would be a real enjoyable conversation. And you don't have to take my word for it. You can go catch a couple of ones I've done with other scientists. You can look them up on SoundCloud. Just type in like Michio Kaku, Neil deGrasse, and I've done several of them with them, and you can go listen to the science, because we do a lot of science here. It's just hard on some nights to do really hardcore science because we do have an audience. And no, it's not that I don't think the audience understands it. I think the audience is pretty well versed in their understanding, because most people who follow us have a science interest. So I don't think that's an issue. It's just sometimes they want us to move on. They're getting impatient. Well, you're sitting at home right now for COVID. People are a little impatient. So, but no, I do appreciate it. If you can, Ruby, look, ICAR@cox.net. You can have me write me right there directly. If you send me an email there, I will give you my personal phone number and my Skype number. Y'all can contact me direct at no cost to y'all, since I know where y'all are. Well, I'm sure certainly pay for the call, but I mean, they don't have to, is what I'm saying. I'd pay for the call. So. But I would love to talk to any of y'all, and we would love to have any of y'all on the network, on the show. It would be a fabulous time by all. And we do have a huge audience, a great following. And these are people who would really appreciate what you had to say. And Ruger, if you want to come on yourself, just write to me. But anyway, I know we keep getting sidetracked. Well, no, there's been a lot of great questions. Ukraine, man.
Oh, one second. I want to plug something else for people interested in science. We do a TV series. The Dr. J.J. Hertek, his wife, Dr. Desiree Hertek, and myself, called
Science
Future
Tonight. Yeah. Sorry, go ahead, John.
Okay, we do a TV series that's called Future Science TV, and we have all our past shows on our channel, Future Science TV, and it's called Mysteries of the Universe. And we interview again, top people. One of our last interviews was Elizabeth Rasher, Dr. Elizabeth Rasher, who passed away 2 weeks after our interview, and she was one of the top physicists in terms of string theories, of multi-dimensions, and actually was involved in remote viewing. And that's just one example. But we've done things on the pyramids, but a lot. It's very archaeology. So that's Future Science TV is our channel. We got, I think, thousands of subscribers, so it's pretty popular. And the show is Future Science TV, Mysteries of the Universe. So I think you'll enjoy that. And again, Joe mentioned, I don't know if you did, but our archives. We have a pretty big archives too.
Oh yeah, the show does really good in the archives. So look, you want to come out and check it out, you'll really enjoy it. You'll get a lot of play out of it. We just moved it back to this slot because it has about 300,000 or 400,000 more listens there on average. I mean, it's the first night back, so I don't expect to do it at those numbers, but it's going to do well. But it's a good place to be, people. You get a good audience. And what's good about this show is even when we get out of COVID, a lot of people are still at home listening to us before they go out on the weekend or go out for the night. And if they do miss us, of course, the archives are available. But soon, probably starting in March, you may only be able to find the video archive if you're a member of the YouTube channel. So, but then we'll talk about that in the future. But guys, if you know a good scientist you would like to have on, if you'd like to have any of the current guys out there in any of the fields that we talk about, because there's a wide variety of fields that John and I talk about. Go ahead, John.
Well, what we're going to do too is we're really, we want the top scientists in each field. And I have lined up a very good friend of mine. I've actually interviewed him 3 times on other networks, Dr. Ron Mallett from University of Connecticut, who's the physicist. He was like in Time Magazine. Spike Lee was going to do his life story. He supposedly is working on a real time machine using lasers. Now, it's not really like you're going to get into it like in the movie in H.G. Wells, but the idea is he's using subatomic particles and different things with lasers and trying to send them back a little bit. And he'll come on, and I'd like to get him on. And I was a professor at a lot of major universities. I taught neurophysiology at Johns Hopkins, and I still have a lot of contacts. I think what we really want to direct this show, because it is science and beyond. We've done a lot. I mean, we've even had John Gotti's Hitman on.
Oh yeah, we've done some beyond. Yeah, there's no doubt. We've done some beyond. That's not live, but we've done a lot of good science too.
Yeah, I think we need to
Well,
stick
we've
more.
done good science. We've done heated science. Y'all should go check those shows out. But
Yeah.
we got a lot. We've got quite a few of these shows out there. Oh, I'm sorry. Hold on, real quick, John. Okay, you're talking about tomorrow. Okay, tomorrow, real quick. Wise Guys, 4 o'clock. Yeah, that's
Oh,
John. That's John, Billy, and Nick. Yeah, they'll be there. Followed by Michelle and I are on all month. So it's the Wise Guys at 4 o'clock, 4 to 5. Be sure to come check them out. And then we're going to follow them with the Gray Zone from 5 to 7. Follow Chasing the Prophecy files. Yeah, we got a really good lineup. It's a different kind of lineup on Saturday, and all three of these shows are unique into what they do. All three of them are. So it's not like we usually do where we theme out the nights. This is unique. So be sure to come check those out. Oh, we got to plug in. Trust me. Trust me and John, we're not going to forget to plug these shows, but I know it is a top of the hour. We usually do plug them. No, they're all doing well. And we've had a little couple of kinks with Wise Guys. But I think we got them all worked out, and they sounded really good last week. The archive last time I checked was doing fabulous. So y'all should be able to go check it
yeah.
out. It's available on all of our venues, so check it out.
I think
Yeah,
the SoundCloud was almost like 70,000.
yes, it was clicking up.
Yeah.
No,
Oh, you know what?
they're good shows.
Let me just give a plug a little bit more for
ahead.
that Wise Guy show, because people may be thinking, a wise guy is another term for a made man in the mafia, which like is a soldier. And what we do, we have three of us. Billy Catello, one of our hosts, was actually a soldier in the Colombo family, and his father was Wild Bill, he was the boss of the Colombo family. And if you remember back in the 80s, there was a bloodbath, and that was his father was boss at that time. And they actually murdered him 6 years later for revenge. And but Billy has been involved and knows, all the mafia people. Don't forget, that's what his father was the boss of one of the five major mafia families on the commission in New York. And he was on.
Books does Nick have? I'm sorry, I didn't mean to interrupt you, but
He was
when
on.
you said that, it made me think about it.
No, Billy was on witness protection. He just got off that, and we'll talk about that. And Nick Christophers wrote a book with John Alight, who was John Gotti's, my very good friend, was John Gotti's hitman and enforcer. And we had him on twice on our show. And
they done really well both times too. Yeah, he did.
Yeah. Oh, he was wonderful. I always like plugging John because he plugs our stuff, but he's been a very good friend.
Let me clarify right quick, because I know we're gonna get emails about this, because we always do when we talk about John. Yes, I don't concede that John was a bad guy when he was young. He would mess you up as soon as look at you. Okay, I'm not going to get into a long spiel about this, because if you want to go listen to the show, you can. John, we knew coming in there may be a little controversy, because he was the right hand hitman. I mean, this guy batted people, did all kind of stuff. But you know what, guys? He served some time down in Brazil, and he served some time in Turkey. So I got to say, the fact that he survived it and came out as a human is amazing to me. All right. It is amazing. Yep. He should have came out just way worse than he ever was. He should have ended up dead or killed a bunch of people, but he didn't. He decided that he was going to save use from his mistakes. And that's what he does. And you can check him out on Netflix and, the series, right as I said it in,
the Netflix series. Yeah.
What is it?
Oh God. Was it New York versus the Mafia?
No, it's Fear City. It's Fear City is what it's called.
Fear City. And John is featured in most of those. And you know what? I got to thank him. We've been good friends for a long time. And usually John doesn't do these other shows, or if he does, he charges a lot.
Yeah,
he came on both times for nothing because of our friendship.
He ain't cheap either.
I really appreciate him, and I may be related. Michael Francesi is another one. I've been trying to get him to come on, and but we're working on that. My mother sister married a Francis, and the third person there's another guy who's big like Billy and Michael and John. And it's taken me almost 6 months to contact him, and he finally did. And he said he would be interested in coming on. But maybe
y'all had a really good guest on a couple of weeks ago, but they had some kind of weird. I don't know what it was. It sounded like somebody dialed modemed up the system. It was weird.
Yeah, that was. Well, I did just to go back. Yeah, John is running the Second Chance program, like Joe said, where he's helping. He says when people ask him, "Have you been in jail?" He goes, "I've been in almost every jail in the world," and then they had to extradite him. And so you're right. He should have come back angry, hateful. And I tell you, he is just been wonderful, wonderful friend to me, and he's really helping a lot of people. And that's the purpose of our show. We had the guy on from Hell's Angels who was the sergeant in arms, the third man in control. But anyway, turn into the show. It's a different show. And it's interesting because it's not fiction. Oh, the other things, we have movie reviews, where we'll take a movie like Donnie Brasco, which, by the way, Billy personally knows the real Donnie Brasco and is going to get him on our show. So we're the real deal, the real mafia people that knew the people. I'll tell you about John Gotti's wedding sometime, but I don't like to, well, that's a personal thing. But anyway, there's a lot of fake stuff out there. Hollywood, like, The Godfather is fake, The Sopranos is fake. A lot of these, and we review the movies sometimes. Nick is good at that. So try to watch tomorrow. What was it? 4 to 5 on Saturday.
Yeah, Nick's the good looking one, guys. So y'all know that, man.
He's
a good looking one, man. I'm just saying, he's a good looking one. Yeah, y'all hate on Nick, but he's a good looking one. Actually, Carolyn. Oh, you told Carolyn. That's Michelle DeRoche. No, we're doing Haunted Forest tomorrow, by the way. Yes, we are. We don't post the website anymore to the day of the shows, just because we were doing shows and we started noticing a bunch of paranormal shows are doing our ideas, because we had listed a year's worth of shows we were going to do. And all of a sudden I was like, and Michelle's like, what the? So we took them down. Yeah, people are just using our ideas. I'm like, screw this. So y'all don't get, now y'all got to go to the website and find out what's going on with the day of the show. But it is Haunted Forest tomorrow. We're going to be discussing. We have 32 of them we're going to be discussing. So we'll see how many we get to. But it's always good. So don't forget Wise Guys, and then you got Chasing the Truth with Sean Graham. They're on the Dark Waters Network, where they're syndicated through us. They're out of New Orleans as well. I'm going to be on a couple of New Orleans shows upcoming. Those will be live on the network when I'm on them. If y'all in New York, I've been on like 14 New York shows in the last 6 weeks, guys. So, and I've been on several in Arizona and several in LA. Wow. I've been all over the place, but talking about all kind of stuff too. No politics, guys. Sorry, move on. On. I see like 80 y'all with the scroll politics. We're not going there.
No politics and no
UK man from. He is from Glasgow. Am I saying it right? Glasgow that's not the UK. I guess it is the UK. I'm sorry. I apologize. I was going to say it was a different country, but it's in the UK. So I apologize. Yeah, stupid Americans. What can I say? So do you think? Okay. That's a good question. He says, so do you think if dark matter exists, is it what causes dark energy? Is it like a process or maybe that gives off dark energy?
All right, that's the next subject I'm going to start, which we're going to talk about the deceleration parameter, which is involving dark energy, and I will focus on that. So I don't want to answer that because it's going to give away what I'm going to be talking about. Let's get any other questions before I do the dark energy. Anything?
Let's see. Rico, no, Rico, that's a dumb question. What is this? Martha? What you got, Martha? Where are you from? Oh, I thought you might have been a friend of mine from New Orleans. So sorry. Well, I got a friend of mine named Martha in New Orleans. So what's your question? Oh, so you're okay. I know. I understand. So I'm going to summarize this because this question is like 8 paragraphs long. So she's theorizing that we're in a spacecraft. You and I, we're cruising along space. We're doing our show, Space Science and Beyond, as we're going through the universe, and we run into a patch of dark matter. Okay, now I don't exactly mean what you mean by a patch of dark matter, but she says at this point, will this help charge the ship, slow the ship down? She says, I know it's not supposed to be any resistance in space whatsoever. She said, but you can't have something physically there and not have resistance. If you're passing through something, it's going to cause something on the craft itself. What do you think it would be? Well, I don't exactly know what it's going to cause.
I can answer that. No, dark matter is passing right through you right now. Your gravitational pull is so insignificant that it would have no effect. We're talking about galaxies, and large objects. For example, if you drop a ball and it hits the Earth and you calculate the gravity, actually the Earth is moving towards the ball and the ball moves towards the Earth. But the Earth is so massive, for all intents and purposes, it's the ball's falling toward is being attracted to the Earth. So no, not the theory that we have now on dark matter. It's like just spread out all over. It's coming through us, but again, we can't measure it. But no, a spacecraft or something like that would have negligible effect. We're talking about galaxies and star clusters and that kind of stuff. Good question, though.
She's theorizing that dark matter could be thinner and thicker in areas. Thinner and thicker. So you're going back to what we were talking about earlier, like a fluid space or something.
That's a really good question. Okay. I don't know how to answer that because again, we haven't even seen it, but I don't think there's anything to rule that out. That would be an interesting discovery. It doesn't seem likely, and I'll tell you why. I'm just thinking on the spot here. Because of the gravitational lens experiments that shows how objects are bent, light is bent around large dark matter, the galaxies in which dark matter is prominent, you would get maybe different bending because there'd be different gravitational fields. So my guess is it's probably uniform, but no, it's a good question. I don't think we really know enough to rule that out. But she'd get an A+ in my class for that question.
Selma's actually writing in. Selma's writing in from New Jersey of all places. Hell out in New Jersey.
Hey,
I don't even know what the name. She's got some city. I don't even know what that city is. You sure it looks like some fake name from some elf kingdom or some shit. I'm just saying that's what it looks like. Anyway.
I miss Hoboken.
I know.
The best seafood, and Baltimore too. That was great.
So basically, then anything traveling at the speed of light or faster, dark matter really wouldn't affect it unless it was a large mass.
Yeah, I mean, you got to realize that our conclusions on dark matter are due to observations of galaxies and galaxy clusters and really large objects. We really haven't. Here's the bottom line to answer your question: we haven't seen or can measure any effects of dark matter on smaller gravitational objects, at least up to now. Now, by the way, which is interesting, there's a lot of experiments done like underground because as the particles from space travel, they get filtered out as they go underground. And some of the scientists are trying to actually identify a dark matter particle. Nobody has yet, but it's some interesting research where they miles under the ground trying to measure and look for dark matter. I'm not really up on that. I just know they're doing it. I would love to visit one of those facilities sometime. So,
well, I'd like to see that. There's a collider in Louisiana, and they're supposed to have been credited for finding micro wormholes. And Gene, to answer your question you posted earlier, I don't know if micro wormholes and micro black holes are the same thing. Black hole seems to be something different than a wormhole. I don't know. I'm just theorizing because both of my theories, so I'm not going to argue with you about it. But I don't know. I mean, wormhole to me means something that would traverse a distance or connect two areas.
Yeah.
Whereas a black hole suggests something that's going to suck up and eat everything that gets around it. So even if it's a micro black hole, it would still have the same characteristics. And as far as we know, these massive black holes we have in the center of our galaxies might have started off at micro, just kept eating and eating and eating until they became what they are. I mean, we really don't know how they got there. There's some massive explosion that ripped the time-space. There's no way of knowing. We don't know yet, but we're going to find out. Give us time.
Joe, this is interesting. I mean, because was part of my study, the event horizons and black holes with my holographic theory. This damn area of astrophysics is so fascinating, isn't it? I mean, all this stuff
because there's so many interconnected things.
I want to recommend a couple books, and I can't find. One is Brian Greene's "The Fabric of the Cosmos," Michio Kaku's "Physics of the Impossibility." I'm holding these up, but if you're just listening, his other book, Beyond Einstein, and Stephen Hawking's book. Most of you probably, anybody interested in physics, have read A Brief History of Time. These are good books for the layman to get a really interesting. I mean, these will kind of blow your mind if you've never read anything like this. And I don't know if you want me to talk now a little bit about dark energy, or do you want to take questions?
Just 2 seconds.
I don't mind taking questions.
I would recommend The Universe in a Nutshell. It's for laymen. It's written for laymen. Don't get me wrong. Some of this, there is some hard math, but for the most part, it's written for layman's. When Einstein did that, when not Einstein, I apologize. When Hawkins did that, when he did it more for everybody who's not a physicist. He wanted just everyday Joe to have at least a working knowledge of physics, and because of him, most of us do. He's one of the reasons I got fascinated. The first time I read it, I was like, wow, I really understand physics. And then when I got into heavy physics, I was like, well, because of him, it made it easier for me to understand. So, yeah, I would definitely recommend it. And as far as micro wormholes go, real fast, there's lots of theories about them. They have been proven to exist. Okay, so we do know they exist, but some people think that they were larger ones that just shrank down and are degrading. Some people think they just naturally occur and they pop up here, pop up there. It's no big harm, no foul. Some think you might be able to capture one and blow it up and make it a larger one where you could travel. I have no idea, people, and neither did they, for that matter. Let's just be honest about it. But we do know they exist, just like we know black holes exist. Even though we can't physically see a black hole, we can see the event horizon. So we do know they exist, and we do know because of our own giant one that they don't always eat. Sometimes they eat, sometimes they burp out stuff, sometimes they take a nap for 1 million or 2 years. So, but we don't know why. Nobody has any idea why they act like that. Some people say they get too full and then they stop eating, and then before they can eat again, they have like a massive discharge back, and then that's one of Paul Levette's theories, the cosmic pulse. So lots of good science. Yeah, John's right. I mean, there's so much interconnected science in here, and honestly, we won't know for 1,000, maybe 5,000 years how much of what we're talking about is hardcore science. Because if you go back just 500 years and you look at what they considered hardcore science and what we do today, it's vastly different. I mean, like bloodletting, worms, it's just vastly different science. And even though they were doing legit science or thinking they were doing legit science by scientific method, it still wasn't the science we do today. And the science we do today won't be the science we do 2,000 years from now. It'll be a different science. So it'll be still the basic theory of science. Science, you have to prove the way you do it, but scientific theory is scientific theory at whatever level of evolution you are. It'll be different equipment, different theories, different mass. Who knows? I can only speculate to what's going to happen in 2000. Look, nobody could even get the future right in 2000. Do y'all all remember all these world fairs that used to go around the world in the United States, and they predicted all this crap that was going to happen in 2000? I'm just telling you, I was vastly disappointed when 2000 got it. There was no flying cars, there was no Jetson house. I mean, come on, people. Yeah, we can't even predict 50 years ahead. You're going to try to predict 2,000 years. I just think if man behaves itself and doesn't wipe itself out or epidemic itself out, that we will achieve greatness in massive ways. And things like John and I are talking about will help us do so. Understanding dark energy, which he's going to start breaking down for y'all in a minute, is something that could change. Dark energy and antimatter. And Gene, save that question for 2 weeks or a week from now. What will happen if antimatter runs into a black hole? I would love to discuss that with you, but that's like 30-minute discussion at least.
Actually, that's a major part of my holographic theory of the universe, of the event horizon, and the two-dimensional astrophysics theory that the universe is actually a two-dimensional, surface, and it projects three-dimensional world, and the event horizon allows conservation of energy. I wanted to ask, I have to mention it too, and I know people that are physicists and professors know this, and I got to make it real clear. I'm trying to explain it, and I know like Michio Kaku does a great job. We're explained it in general terms.
He makes dumb people feel smart.
But to really understand this stuff, you have to know the mathematics. The mathematics is how it was discovered, because and that is not easy. And most of the math is like differential equations, calculus, partial difference. It's higher level. So
something gives you headaches.
Yeah. Oh my God. That's my favorite subjects though. But the problem is you simplify it. Many times you simplify it and it's not correct, but you do the best you can. And that's what we're trying to do. And again, to summarize, these are basically things we can't see, we can't measure, we can't touch, but mathematically, gravitationally, they explain some of the greatest events in the cosmos. And that is something. And this is the next event, which where dark energy comes in. And basically, here's the interesting thing. After the Big Bang, okay, what scientists think when the Big Bang happened, the first 7 billion years after, it was like um, it expands. The burst first expands, and then over the 7 billion years, it starts to slow down. It's like you're driving and you come up to a toll booth and you got to slow down. So they thought the universe was actually decelerating. It was actually coming together. It wasn't expanding. It was contracting. And that was been the recent theory until dark energy came in, because what it is like now is because of dark energy, that we have noticed the universe is expanding. And by the red shifts and microwave radiation, this stuff I don't have time to go into, but the universe is actually expanding. More space is being created, which we think is the dark energy. And we don't know. This is just opposite of what we thought. So, I guess a good way of looking at it is when the Big Bang happens, the matter started to expand and then start to slow up, and it's like when you hit the toll booth, it then speeds up because the universe is larger and larger every billions of years, and it's expanding. And this is, by the way, we use microwave radiation, background temperature, and it gives us this. So now, dark matter comprises, we think, about 70% of the universe. Remember, I said 30% or less is energy. Okay, and it could count for the accelerated expansion. We're not sure of that, but we think it's expanding. And the way it happens is it's really strange. I'm skipping over so much stuff here, but I was trying to think of an analogy I could do over the radio instead of like on a blackboard, but like a little tit-tat-toe,
Yeah.
So let's say you had a dot on each of the two sides of the tit-tat-toe thing, and that in space. Well, the tit-tat-toe increases in size, or another tit-tat-toe board goes in the middle and spreads out the two particles. So now they're further apart. And that's kind of how the universe is expanding. Space is being added in the cosmos, which is the dark energy part that's expanding our universe. And I wanted to read a quote from Michio Kaku about that, because this is like, it's very interesting about, if I can find it, about the dark energy. I hope I can find it. No, that isn't it. Maybe it's in this one. So here's one reason that it may not be just a total thing that is made up, because what's happening is that it's explaining something. Oh, my marker just fell off. But well, anyway, so the dark energy is what is responsible for the expanding universe. And it eventually, we think it could just freeze out and everything stop after a time. Just, everything just moves away, gets cooled down to absolute zero, and everything stops. And scientists, that's totally opposite of what they thought when they were basically, studying the universe. And a lot of this is due, again, because see, when something's moving away from you, there's a red shift. It's like when a train goes by you, you hear this change in frequency, right? Because the wavelength of the sound is spread out because the train is moving. So as far away objects in space move away from you, you see a red shift. When they move closer, you see a blue shift. So looking at the red shift and the microwave radiation, which gives us the temperature of the background radiation of the universe, we determined that now space is actually expanding, and that's due to the dark energy, which is a gravitational effect. Now, again, what is it? I know the question is, well, can you tell me what it is? Well, we don't know. I can't even tell you what dark matter is. I can't tell you what dark energy is, but I can tell you what it's responsible for. It's responsible for this movement. Now, dark energy is basically a version of Einstein's cosmological constant. Again, I wish I could do this mathematically, which is an unchanging energy that pushes space to expand. So if you want to, after the show, look up cosmological constant, this was Einstein had to put this in his equations or it would show the universe is collapsing. So that's kind of really funny. So his field equation actually is associated with the concepts of dark energy, even though he didn't believe in the theory of dark energy, but the equations wouldn't work unless he put in this constant, which is called the cosmological constant. And this is where we think dark energy comes in and can explain the expansion of the universe. So let me try to say that another way. I know it gets very confusing without the math, but Einstein, in developing this differential equation that describes space-time, right? Einstein's equations describe space-time, gravitational effects. He needed to add a constant term to avoid having the universe collapse on itself. So it was just a term called lambda, an arbitrary term, the cosmological constant, and that was thrown in his equations to prevent the universe from collapsing, which his equations would do. And this term balances the attractive forces of energy, of gravity. It balances the attractive force of gravity contributed by all the matter in the universe. And by doing that, it shows that matter is going to expand in the universe. The universe is expanding and not contracting. And it's like, again, really hard to explain this without the mathematics of this. But another way of looking at the universe expanding, it's not that the particles are moving away from each other, but more space is being added, which is the dark energy part of it. And that is really weird when you think about it. Like you have two things separated and now they become further apart because more space is added in between them. That's a hell of a concept to put your head around. So I probably just lost most of the audience, but that's kind of where dark energy comes in. And again, I can't reinforce enough that we don't know what these are. We can't measure them. We can't define them. We can't see them. But by assuming these constructs of dark matter and dark energy, it explains how the galaxies hold together, why they rotate the way they do, why space is expanding, a few other things which I won't go into, but it explains so much that if it's not dark matter, it's got to be something else, because if you just use the gravitational equations and math that we have without assuming something else, it doesn't explain all these cosmological phenomena. It's amazing.
No, it doesn't. It definitely doesn't explain it.
And that's why we need creative people that are listening now, these people that are asking questions. The person that asks, is dark matter constant throughout the universe? Could it be? I mean, these are good questions. These are questions that I hope
we got one question I definitely want to get in, because I just like the question, but hold on, let me grab it. What did I do with it? I just had it. I set it aside so I wouldn't forget about it. So where did I set it at might be the good question. Where did I just had it a minute ago? So he wanted to know if basically if these dark matter or dark energy could be used as a form of space travel. Like he said, how we're putting ram scoops on airplanes to scoop hydrogen now so that they can go in and out of space. He was wondering if we could do the same thing, if there was a way we could attach some type of scoops that would actually suck up the energy or suck up the matter that could power faster than light star travel. I would love to see that, my friend.
This guy sounds like he could be a future Elon Musk, huh?
I know. Maybe you ought to apply for a job with the man.
Yeah. No, I actually never thought of that, because, you get to the point where you're talking about something you don't even know exists. And then to go beyond that is what this guy is doing. It's a very interesting question that maybe once we discover it, let's say one of those underground facilities can identify, maybe it's an exotic particle, then that means, can we capture them? Can we concentrate them? Can we use them? Excellent possible technological application
It would
of
be
whatever
fabulous
it
if they could
is,
do
you
that.
know?
Oh yeah. But we until we get out there and know people. I've heard speculation on what's the nearest place we could, if dark matter exists, what's the nearest place we could access it at, and it's a good distance from here. So this isn't a technology we're going to possess anytime soon, but there may be things that bring it to us. Because shit falls on the planet all the time. And
Oh,
are you
that's
talking
interesting.
about Omarosa? What's the name of that comic? No, I've been look. We only talk about this for a second, and you can bring this up on another show, but not tonight. That comet you're talking about, and I've seen all three of the scientists who wrote articles that it could be an alien craft or an alien probe. It could be, but it could just be some rogue ass comet that we've never seen from deep space. So it's like everything else in space at this point. Very interesting, very fascinating, very limited evidence on what it could not be. And there is some evidence that leans that it could be something structured, but that's not for the night show. That's for another show. That's for an entirely different show. John and I will actually do a show on deep space objects coming in that could possibly be something other than asteroids. The Russian-backed, they just found that signal in Proxima, so that could be something interesting too. It might be.
Yeah.
I'll tell you what's most interesting about the Proxima signal versus the WOW signal is the WOW signal, because of the way it was found, was in deep space, and there are things it could be or maybe not be. This one, the one in Proxima, can only be a signal from Proxima or from Earth. So it limits out all the rest of the cosmic background. So it's very significant to researchers because it's one or the other. And it's looking more and more like it's not from here. And everybody agrees that it is a structured signal. It is not a natural forming signal. This was made by someone. So if it turns out to be alien, whoa, whoa, whoa. If it turns out to be us, well, it was interesting to talk about. Y'all got to learn not to get so excited. It's fun to get, yeah, but let the science work it out. They're a little slower than the rest of us. I mean, I predicted 35 years ago that we'd find water and life on Mars. Well, they finally said we got water, and now we're pretty sure we're going to find life. So just give them time. They're a little slower than we are because they got to be more methodical. We can just blurt it out there and hope we're right. That's the difference. But they have to prove it. See, I can get on the radio and say all night long, yeah, I'm pretty sure there's life there. And in reality, I knew there was and would be. But proven life is there is a different thing. It's like extraterrestrials. Proving they exist is a far different thing than saying they exist. Yes, it is, people. It is. What's that, Bruce? Oh, wait, hold on. Let me grab this one. Hold on. I agree. Bruce said first he wanted to compliment you on your knowledge on the discussion on the topics we were talking about. And he said he appreciates the idea that we're willing to discuss how what applications theoretically dark matter and dark energy could be used for. Well, of course. And we're all hoping it turns out to be exactly that.
Fantastic. Yeah.
Yes, you do. And antimatter is not the same. Go ahead, John.
I mean, you people listening, you young people, you students, you don't even have to be a student, just curiosity. You can come up with the answers to some of these or the speculations. And like I said, remember Einstein was in a patent office when he wrote the general theory of relativity, the photoelectric effect. I mean, now here's, I really want to emphasize this. So this is a perfect time. Then we can go back to the questions because I actually would rather do a whole show on questions. When I was a professor, I'm a retired professor, I was taught for 20 years, but the questions, I always like questions even better than lecturing because it brought out what people were interested in. But keep in mind, ideas are cheap. You can come up with hundreds of ideas. Speculations, I call them, guesses. Scientists call them
ideas before, but okay.
I'm from New York. I didn't say sandwich. Oh my God!
I just tease it. What was that? But Maurice. Ain't that the name? That song, Maurice. I know there's some song with Maurice's name in it. Space Cowboy. Is that what a Space Cowboy always said? Wait, hold on. I keep losing questions tonight for some reason.
Well, let me finish my statement about this. That when I was working in the superconductivity lab, I was doing research on simulated motion of flux tubes. The head of the lab was Hans Meissner. Actually, was my boss. He was the son of the Meissner effect and superconductivity. And I never forget, he would always not yell at me, but always say, never assume anything. I probably heard that 1,000 times from him in that lab. I was working on an NSF grant. Never assume anything, over and over. Every time I assume something, never assume anything. And I really copy that now. And I always say that. And a lot of these new age people think a hypothesis is a theory or law, and it's not. It's a guess. And as you know, Joe, a hypothesis is like, well, maybe it's late outside, or this is going to happen. You got to then collect data. You form a hypothesis, you collect data, you analyze it. Then does your predict what you found, your theory, does it predict other phenomena that you would not have known it predicting? So it takes a long time to go from hypothesis to theory to law. And so when you hear things from others, don't just assume it's true. Ask for data, ask for evidence, be skeptical. And that's the scientific method. I try to live your life like that.
It does. And John's got a very valid point here, because you'll hear a lot of people say my theory about this. What they're actually meaning is their hypothesis.
Yeah,
it's a very different between hypothesis and theories. There's a lot of ground difference in there. There's a lot of change difference in there. Like somebody they said, well, I heard you say a theory. Well, yeah, because I've been working on for 25 years. So it is a theory, but it was a hypothesis when it started out, and it had to be brought to, and by the way, the theory doesn't mean it's true. It just puts it a lot closer to being true. It just
exactly.
It's still other parts that has to go through, including peer review. So, Jack, I know a lot of people get pissed off about peer review, and I do understand it, because there are a lot of pipe smoking, cigar smoking, stuck up professors out there. I'm not going to lie, there are, and they don't want their theories being damaged.
And
I do understand it, but for everyday people, we need you to go through the process so that then we can fight about it. Because, I tell this to scientists all the time, look, when you do science, don't just write it for your friends. Write two versions. Write a version to be peer reviewed, but write a version that the layman can understand. Because if you get the layman on your side, you're much more likely to get the funding and the stuff you need to prove your theories. And you'd be surprised. I've talked to several, especially when I was younger, I used to attend a lot of physics lectures, a lot of astronomy lectures too. But anyway, enough about all that. But I used to tell them all the time, make it to the layman. I said, y'all are selling to the wrong ones. You're selling to each other. I said, when you walk into someone's office and you want $5 million and you're trying to explain to him why, and he's looking at you like you're stupid, speak English. Well, if you would have been selling this to the public the whole time, he would already know what you're talking about and be willing to give you the money, as a lot of scientists have figured out with SETI and other programs like that. You have to make science approachable for the public. I'm not saying I don't expect you to make them understand. Okay, if you're high school educated, college educated, wherever your education level is where you are, plus what you've learned in life experiences. So I want you to sell to that crowd, like Michio Kaku does and Neil deGrasse Tyson. When they publish something, they put it out so everybody understands it, including science and everybody else. And it's a good way of doing things, because they get behind them and push their theories for them, which means other scientists have to now disprove that theory because he has the populace behind him. And Michio Kaku has been great for using this to get real science done. And so has Neil deGrasse Tyson. And he's not done. Elon Musk has also used this to get great science done. It just makes sense. Look at Elon. He is a salesman and a scientist. So he wants you involved. That's why he shot his car into space. He wanted the layman public involved. He talks about his people going to Mars and how they're going to live every day. He wants you involved. He puts it in science that you can understand. He goes on shows and smokes pot. He's now the richest man in the world, by the way. And he'll go on a podcast and get loaded and explain to the world how he's going to colonize Mars and how he's going to revolutionize travel between New York and Cali and making it under 30 minutes. I mean, this guy is brilliant, and he wants you people to benefit from it. Not only does he want you to benefit, but he wants you to understand what you benefit from. Just think if Bill Gates would have took that approach with computers, how much more enlightened our species would be today. Because most people have no idea how a computer works. I'm just going to say this outright, people. I had people all the time, well, I'll ask them, you know how it works? Well, no. I know how Windows works. I said, but that's just a program. And I said, do you know how to computer? No. and it's just one of them things.
Hey, I remember learning on the IBM 360, but I want to say something first before we run out
Dinosaurs.
of time.
Go ahead.
That's how old I go back. But anyway, I wanted to just for maybe new listeners who aren't aware of my work and what I do, I want to take just a few minutes and mention also my contact info. I mean, we're co-hosts. I'm not a guest, but I still want to get a plug in for PizzaPyramid.com. But I'm basically a trained scientist, and here's why I'm different than most people. And Joe was right with what he was saying. You got the academic people on one side who think all this paranormal, psychic, UFO stuff is garbage. Then you got the New Age people who believe in everything out there, Planet X and this and that. I'm in the middle. I'm a scientist that studies the paranormal. Now, I have 11 books published by Barnes and Nobles and Inner Traditions on the paranormal, on magic, on psychic, on clairvoyance, on crystals. I do scanning electron microscopy. I use the most latest scientific equipment to study the paranormal. I was a spokesperson for the Ukrainian and Russian pyramid and psychic research for 8 years. So I am a scientist. I'm a believer. Maybe, Joe, the best way to say this is I'm a believer. I'm open. And I'm a scientist, but I'm open. I believe in these other realities, but I want to study them scientifically, or at least statistically, because a lot of the paranormal stuff is not repeatable. Like if you drop a ball, it always falls at 32 feet per second squared anywhere in the earth, the eliminating rotation of the earth and air resistance. But psychic phenomena is not always repeatable, but you can use statistics. You can use other means of measuring it. And I think that's where the future is going to lie. Now, I didn't get time to talk about it tonight, maybe another show, but I take this black matter, dark energy, dark matter. I was going to say dark matter matters. How's that? And try to apply it to some of my paranormal work. Like, are there some of the hidden dimensions of string theory in this dark matter, or of the metaphysical, magical realms, or whatever? That's where I like to take it to. I like to take the basic science and then try to apply it or expand it into describing paranormal events. Now, I developed a multi-holographic model of the universe, and mathematically, I showed how déjà vu works and missing time. Now, not everyone will agree with me, but it's mathematical, it's graphical. But so I am putting some meat into the guesses, let's say. It's still not even a theory yet. It has to be published and tested. And that's what I advise for people out there. I'm not saying this to brag. I'm saying is that you need to have a solid scientific background and approach to whatever you're trying to promote or believe in. If somebody says, I saw the boogeyman outside, you want evidence, you want a picture, you want to measure it, you want whatever. So the idea is, yes, use common sense, you be skeptical, but also be open. If I wasn't open, I would have never written those 11 books. I would have never done 20 years of radio and talks on promoting the different types of paranormal phenomena, which I think is something important for our future, that we are more than just molecules and atoms. We are a spiritual being, and our goal in life is to discover that spiritual being, those higher realms. I wouldn't promote any religion, belief, or faith, but the idea that there's some kind of energy, power. I almost look at the mathematics, or God as a mathematic. I had a theory that the whole universe, God, whoever, or it just happened, was created, and we're a giant mathematical multidimensional equation. And when the equation equals itself out, that's the end of the world. But I mean, again, that's one of the guesses. You'd have to come up with something. But keep thinking. But write your ideas down. Keep a diary, and then think of ways how you could test them. And don't be a sucker for everything that comes around. Don't assume anything. If I could emphasize that. And again, you can contact me either through Facebook or GizaPyramid.com, and email the director, and I'll answer you. And I would say please follow us, because we're going to have very interesting people on from different areas of science. And I was at different universities. I know a lot of people out there in all the major fields, and so it's easy for us to get top-notch guesses. Yes, we're hoping to get. Well, I hope we can. I don't know. He's so big now. I'd love to get Michio Kaku on. I know
He's
you've
he's
interviewed
he's
him
pretty
once.
big, but
You know,
I've interviewed him. I've got 3 interviews with him, but
he's great.
he's usually usually if you can get hold to him, he's usually pretty. As long as he's not super busy filming, and I don't know what kind of schedule he's got right now. I mean, so he's easier to get on when he's on a book tour, because he's selling his books. So everybody wants to be on radio when they're selling their books, but. When he's doing a lot of TV, he's hard to get on. Last time I had to schedule in between his shows, but he's a great guest, guys. He's a lot of fun,
Yeah.
and we will. I got his number somewhere, so or I got his publisher's number somewhere, so we'll get him back on. He loves doing science. He loves talking science. He actually loves to get on a show with hosts that actually know science. He had such a good time when him and I were talking because, first off, here at UFO on the cover, so he was thinking alien, that black crazy man. Why is he doing this show? And he didn't think there's going to be any real science. And we got into deep science. He was like, "Wow," he said, "This is it," because he had a good time. So, and
And
I like geeking out.
he's a nice guy too.
He is. He's a nice guy. He's laid back.
We used to email back and forth, and my son was in college at that time, interested in physics, and he sent me some articles from my son. So I didn't even ask him. So he's a very gracious and wonderful person. How are we doing with time, Joe? Because I know we got
We got to get ready to go because coming up next is Kathy Belsky, guys. She'll
yeah.
be on.
Let me just do it my closing, and then you can close it. But I want to thank everyone for joining us tonight. And I apologize for sometimes throwing a lot of things out that take time to digest, and also we simplified them to hopefully you can understand them. But those books I mentioned, I totally recommend those if you're interested in this area. And keep thinking, keep imagining. But remember, with every speculation, every guess, every hypothesis, you got to have data, evidence, and proof to show that there's something to it. And like Joe said, have it move from a hypothesis to a theory to a law. I mean, it takes time. It has to be peer reviewed, but don't let that discourage you. If you have an idea and you believe in it, follow it through. And I encourage you. And I wish you all well, and I wish you success. And these were really great questions. All the people that called in would get an A+ in my class. So I'm 70 years old. I've been around for a while, and as I mentioned, I call myself semi-retired because I feel I still teach. I don't think I'll ever stop teaching until the day I die. So, but thank you, thank you all for listening, and be safe these days.
Yeah. Well, coming up next, guys, don't forget Kathy Belsky will be up in just about 10 minutes. So y'all please stay tuned for that. Don't forget, come check us all out tomorrow. We'll be on starting at 4 all the way through about 9 o'clock. So check out all 3 shows. You'll enjoy them. A lot of interesting stuff on there. Host chats on Mondays. Whoever asked me that question, it's 5 to 7 on Mondays now, so you can catch it over there. And you never know who's going to be there. It's just different hosts every week. But no, I mean, me and Dell and Lori and Mike's going to be there, but you never know who else is going to be there. So they're always a lot of fun. And it's always a wide range of topics. And thank you everyone who attended the party shows. They were big successes. I was amazed at how many people showed up, especially for Christmas Eve. Everybody was drunk as hell. And oh yeah, well, Dell and him stayed. We did 4 hours and then I left. But I left Dell and him on, and they were playing music and getting drunk for like 7 or 8 hours. But they got a song on there. I got banned in a country, so I got to go clear it off because YouTube won't let it play. Part of it play anyway. But they had a lot of fun. Everybody had a good time. It was just a laid back show where everybody was enjoying talking about whatever they wanted to talk about. And no, it wasn't science, and it wasn't paranormal. It wasn't UFOs. It was just the Christmas party was mainly booze and food. I'm just going to be honest about it. And the New Year's party was a little bit of everything. We did talk a little weird stuff, but mainly, we tried to stay away from the depressing stuff like COVID and stuff like that. Because, we all got to hear about COVID every day. So why bring it up more than we have to? If you don't know how to stay safe from COVID, there's nothing I'm going to tell you that's going to change it. Oh, and before we go, I got to again, everyone out there in the UFO world, Angela Joyner had passed, so be sure to pay your respects and to the family and all.
Condolences, yeah.
And and they died for her, and her husband died from COVID. I know Randall had passed 2 days ago, and they were moving her to ICU on the 6th. Today's the 8th, and then it was published, and it was, like I said, it was publishing on my pages earlier. So she used to be a reporter and for one of the local Texas papers, and she ran across the Stevensville case and broke into it, and that's how she got drug into the UFO world. And Stephenville was an interesting case too, and there's so many nuclear power plants out there. But anyway, we got to go. Kathy Bilski's probably cussing me in Hawaii and whatever the hell that is. Yeah, she probably spoken some of that good Maui, going, get your ass off my airtime, buddy. Well, she got a big 1,000-pound crystal there. The thing is as big as my car, man. I'm not kidding y'all. Yeah, you have to see it. Sometimes it's behind. It depends where she's sitting in her shop, but yeah, she got a crystal shop in Hawaii. Yeah, I mean, what kind of life is this, man? No, that's what I'm saying. Lord have mercy. I'm in the wrong line of business. I'm got to do all kind of stressed work and shit. But again, guys, I want to thank everyone for tuning in. Really, a lot of good questions tonight.
Thank you.
I know there's a few we didn't get to, but a lot of those questions really need to be for other shows. And Marco, I will tell you this theory real quick, and then I got to go. Okay. Billions of years ago, there was one single race living in the universe. That's it. It was a different kind of universe, and there was one single omnipotent super race living here. And there was one massive black hole that just appeared out of everywhere. It was just starting to just slowly but surely eat their worlds up. They were everywhere, and it just kept on. And then somebody got the bright idea to drop a super massive antimatter bomb in it. And guess what happened? The Big Bang. So thank all them super omnipotent races, and that's how we got here. I know. Another theory for y'all to be endorsed with. But we got to go, and thanks again for tuning in. See y'all all in a couple of days. Actually, I'll see all y'all tomorrow. So good night. Stay tuned for Kathy, and be sure to come check us all out on Saturday.
Good night, everyone. Good night. Thanks, Joe.